Okay, so good morning, class. We're starting chapter 3. Let's see, we just went over the test chapter 1, is that right? With corrections. And so we'll do, on Friday, we'll do chapter 2 test with corrections. So we'll go from there. Anyways, chapter 3 is about radian measurement. So let's talk about this here just to make sure it's clear in our mind. We have degrees, is that right? We have degree measurements? Actually, no, let's back up a little bit. How many have seen radian measurements before? What in the world? Have you seen that? In geometry, maybe? Grant, remember that or no?
The word.
The word, okay, that's good. All right.
I've heard of a radius.
Yeah. Radius, that's right. Close to it. Yes, radius is close.
Radiation, radical.
Well, let's not go to radiation. That's a little different. That's the death thing that you're talking about. So let's go with it here. So we've got radian measurement. So we have a degree measurement. I remember that one. And degrees could be done in 2 different ways. Is that right? As we've seen on the test that we just took. Degrees could be done in decimals, right? Or degrees could be done in degrees, minutes, seconds. You just break it up into smaller pieces. So we got those 2. So pin that somewhere. We're good? And so we're going to start a whole new measurement system called radian measurements.
Yeah.
Yes, cool. Yes. So your calculator has 3 modes. One is degrees, one is radian measurement, and one is, it's called grand. Have you seen a GRAD on your calculator? So
Mine keeps automatically trying to set it up for radian.
radian's usually the default for things, almost always. So on your calculator, that's degrees or radians usually are done. Gradient, maybe some engineering stuff is done with that, but otherwise no. What grand function is really, it's kind of funny. It's the unit circle, but it's broken up into 100 pieces. That's what it is. So it's almost like this nice whole number, right? And then you break it up so each quadrant is 25, right? And then you go from there. So it's a different way to do the unit circle. Broke it up into 100 pieces as opposed to 360. That's all. So radian measurement. So let's go. Before we get to radian measurement, we're going to look at 3.1 is just something called the, as long as this thing gets started, there it is. It is the reference angle. Let's see if I can get this. Oh yeah, there it is. Okay, sorry, switched it to the correct screen this time. Okay, now we're good. All right, reference angle. And once we get done with the reference angle in 3.2, that's when we're going to start getting into the radians and radian degree functions here. So let's go with it. All right, am I missing my mouse? Anybody see my mouse? No, did I take it? Okay. All right, so let's go with a few things here. So 4 things we need to do. Figure out what in the world is a reference angle to begin with. Use those to find the exact trig functions here. Let's use our calculator sometimes. And then we'll figure out which quadrant we're in and the value. So let's jam. First things first is, don't need to write this down. But what does a reference angle help us with? We will find out that the reference angle is pretty much the same across all 4 quadrants. And so what we really want to do is we want to figure out if we can really get the values of sine, cosine, and tangent in quadrant 1, we don't need the rest of them. In fact, you should realize, hey, you know, we always make like 30, 60, 90 triangles, right? We make in all 4 quadrants, right? We make 45-degree angles in all 4 quadrants. So if we get this little reference angle down, then we don't need to memorize the whole entire unit circle, just one quadrant, and we're done. Okay. Don't need to write all this down, except for, well, let's see. As long as we understand this little guy right here, this little thing on the bottom. Let me use my pen. Yeah, I do have my pen. Okay. This little piece right here. was using my pen, okay. I'm gonna switch things up just real quickly here. This is not doing what I want it to do. I'm gonna go to here. Just the screen itself. All right, you know my to-do list now. Okay. Sorry, let me change things around. My pen is not functioning the way it should. Bring this down to here, and I think this will be a lot better. Yes, a lot better. Okay, that little guy right there. It's called Theta Hat, H-A-T.
No, you made that up.
No. It has a hat.
That's impossible. That's adorable.
And so Theta Hat,
Is it just a dash over the top?
it's almost like this little, it's not the straight dash, it's like almost like an upside down V, just a small little upside down V. And so this guy is going to be a reference angle. Notation, and names for things.
Yeah. It's like, okay, we need a name like 20 minutes by tonight. This one's.
All right, with it, let's go with it here. So we're going to find. Name the reference angle. So reference angle is always positive. It's always between 1 and 90. Oh, sorry, 0 and 90. And it's going to come off the x-axis always here. So let's do the first one here. How about, oh, let me let you guys draw it yourself here. So 210 is what I have. You can give me the reference angle for 210. And so as we draw it out, we go like this. 210 is going to be, let's see, that's going to be 90. That's going to be 180. So it's going to be about right over here. Here's my angle 210. And the reference angle, it's going to be this little guy right here. So it's always connected to the x-axis. 30 degrees. All right, we good there?
Wait, why would it be 30?
So it's the angle that's made by the terminal side and the x-axis. It's the difference between those.
Oh, okay.
I got two more for you here. How about one negative 153? Some good fun stuff here. I think I can squeeze in C at the bottom here. Let's see, that's going to be there, and then 339 degrees. Now I'm going to do B as well. B is 45 degrees. Let's see if we need to do one more. We got time-wise, okay. We probably won't get through this section today, but we still get a little bit here. So all yours, go for negative 153. Which quadrant? Quadrant 2. I'm thinking maybe quadrant 3. What did they say? Because it's a negative. I'm going to go clockwise, right? So you're going to go negative 90. That's already going to be negative 180. So it's a little too far. So here, we're stuck again here. Negative 153. Reference angle still is always positive, and it's going to be the difference between the x-axis and the terminal side. Again? 27? Perfect. And what are we doing to do that? I think we're going like this. Is that right? 180 minus 153. That's 27. Okay. So 27 degrees. Okay, 339. Which quadrant? 4. I'm going to go with 4 somewhere over here. And here's my 339. And give me the reference angle. In a whisper, we're going to go 21. 21 degrees. And this time, let's see what we're doing here. We're taking 360. Is that right? 360 minus 339? And it gets us our 21 in a whisper. Okay, bless you. 45 degrees. Quadrant 1. I know that to be quadrant 1. It's right here. That's 45 degrees. And the reference angle is 45 degrees. Oh, hold on. So let's kind of see how this works out. So in quadrant 1, because we're starting from here anyways, right? Quadrant 1, everybody agree the reference angle is the same thing as our angle? Cool. Bless you. In quadrant 2, let me do one more. Let's do E. Let's do E. Get some things established here. In quadrant 2, I'm going to go with 140. Let's do 140. 140. So let's do this one. So 140 is in quadrant 2. So are we okay with it being here? That's 140. And then aren't we just really just shy of 180? Is that right? Mm-hmm. So it's almost like, how much do you need to get in order to get to 180? Perfect. Okay, so let's do this. I think we're starting our list now. So off to the side, if theta is in quadrant 1, let's see if this makes sense. Our reference angle is the same as our angle. Are we good? Let's start this little process of putting things together here. Okay. If we are in quadrant 2, let's see. Notice what you did with how did we get to 40? What's the mathematical process? I think we just go 180. Yeah, we go 180 minus 140. So in this case, tell me if you guys agree. Reference angle is 180 degrees minus theta. Good? Good enough? Okay, so let's go on to quadrant 3.
Wait, so in quadrant 1, does the hat thing always equal just the angle?
Yeah, because we're starting at that terminal site. And then as the angle starts off, you are looking at the distance from the x-axis already, and they both start off at 0, 0.
So like say that the angle is like 30 degrees. Would it be 60 degrees?
As a reference angle?
Yeah.
No, still should be that, because your angle here, let's say that's 30 degrees. Yeah, you go back to the x-axis. Cool, no problem. I think Drew would say light bulb. Light bulb. No, there is not. We don't ever think about the y-axis as anything special. He's lonely. Okay, how about 228? So think about the operation you're using to get to that, right? We are in quadrant. 3, yeah. And so now we're thinking more of the operation that we're using to get to there. How do you get the reference angle if you're at 228. What's that guy? And what did you use to get there? Perfect. Tell me if you guys are okay. 228 minus 180 this time. Is that right? That's 20, 40, 48. Everybody good with 48? For this one, but then our formula is going to be theta minus 180 this time. So notice it's always a connection between 0, 180, and 360 because it's always the x-axis you're dealing with. And so let's go back to our 339 angle. Notice what we did over here. For our angle in quadrant 4, now we take it from 360. Are we good? It's the 360. Boom. Okay, so theta, if it's in quadrant 4, theta hat is 360 minus theta itself. Are we good? Bless you. Okay, are we good there? So maybe write this down for sure, just so you have it. And what's the reason for it? Is because we don't always want to graph it and then go with it. We just want to use a quick little mathematical operation and done. We good? So now let's do the mathematical operation. This EFG. Good. I'm just looking to see, make sure you guys are done writing here. So now, G. Give me the reference angle. This one, don't graph. Bless you. So reference angle to 309. But don't graph it, just give it to me. What's the answer is? And so the only component that you probably need to know is this right here. So the only little piece that we probably want to know is in which quadrant really quick here, and this should be at our forefront of our mind. Oh, 270. So I think we know that one already, right? But just as a reference, there it is. 0, 90, 180, 270. So as soon as you pass 270, you know you're in quadrant 4. And so without graphing this, it's going to be 360 minus 309, 51 degrees. Done. There we go. Okay, next. I think I have a little time. So now what do we discover? Remember how we have our trig functions are based upon some definitions here. So let's go to this one. Let's go to something called the reference angle theorem. Ooh, sounds amazing. Reference angle theorem. So if I have, let's just for an example here. Let's give you the theorem here first. 5 minutes to go here, reference angle theorem. Dun, dun, dun. So trig functions are equal in all 4 quadrants except for possibly a sign change. And I'll read it back here. So trig functions are equal in all 4 quadrants. So trig functions are equal in all 4 quadrants except for possibly a sign change. And let's see, just real quickly here, see if this makes sense. I'm going to look at sine of 30 degrees and sine of 150 degrees. I'm going to speed up just to show you kind of the cool thing here. All right, so sine of 30 degrees. Ooh, help me out here. If this is 1, anybody tell me what the coordinates are here? Isn't opposite my 30 is always half my hypotenuse, is that right? And opposite my 60 is always root 3 over 2, right? It is always a root 3 times that. We good there? Are we okay with that? We should have a good knowledge of that. And so my cosine, my x value is root 3 over 2. My sine value is 1/2. Are we good there? Are we okay getting that triangle set up? Just want to make sure. Let me bring that in a little closer here. Okay, so sine of 30 degrees, tell me if you guys agree, is 1/2. Is that right? Next. Move this a little bit this way. Okay, so then if I do this one, 150 degrees. Talk to me here. If this is 150 degrees, what's my reference angle? 30 degrees. So that means if I do this right over here, this guy is still the same. The length along my triangle is still the same. Are we good? And the height of my triangle is still the same. The only change is the switching of the signs. So this one, it would be a negative root 3 over 2, but the 1/2 would still be the same. So notice sine of 30 and sine of 50, it's all the same. Are we good? Okay, how does this help us? It helps us in the fact that we just need to memorize quadrant 1. As long as we have quadrant 1 memorized, we can pretty much do all the other quadrants based upon that stuff. Are we good? So the question is, how do we memorize quadrant 1 quickly? We'll put this rest of it together on Friday. So, but I want to show you the nifty little thing here. So trig functions here. This is the secret of trig. You guys ready?
Wait, did you say that sine of 150 equals 1/2?
Still 1/2. Yeah, it was the exact same because our height of our triangle was the same exact spot. So if you go from 0 degrees to 30 degrees to 45 degrees to 60 degrees to 90 degrees, that's all we need to know for these trig functions here. So if I do sine x, or sine theta, I should say, right? Sine theta is, what is it on 0 degrees? 0, right? And then it comes up like this, right? It comes up, comes up. Well, the funny little thing is, if you write sine is like this, is the square root of 0 over 2. What's the square root of 0 over 2? 0. I should erase these for now. And then if you take the square root of 1 over 2, what is the square root of 1 over 2? 1/2. Square root of 2 over 2, same, is that right? Square root of 3 over 2, same. And the square root of 4 over 2, 1. Check this out. These are all the sine functions from 0 to 90. All in that little fun little place. So then cosine is going to actually work the exact opposite way, right? We almost like start off from 90 back to it, or cosine theta is going to be the square root of 4 over 2 first. Then we go square root of 3 over 2, square root of 2 over 2, square root of 1 over 2, square root of 0 over 2 is the way backwards. All right, so how about a 1 over here, a root 3 over 2 here, a root 2 over 2 here, 1/2, and a 0. Are we good? And as long as I know sine and cosine, am I good with everything else? Yeah, now I can do tangent. Tangent is just sine over cosine, and I get that one right away. So that's cool. I like the reference angle theorem. I like this little setup right here.
Wait,
And
so
that's all I
is
need.
that the reference angle theorem?
So remember in quadrant 1, the reference angle is always equal to the angle itself, right? And so that's what allows this whole concept of you just need to know quadrant 1. So you know quadrant 1 very well, and you get the rest by reference angles. Okay, with that nifty little trick, we'll stop for today. We'll continue 3.1 after we look at the chapter 2 test. All right, and have a great day.